Alright, so welcome to Economics Malawi. Today we are continuing with our Stata lessons for beginners. So today we are doing lesson 6. In this lesson, we are going to introduce two important concepts. We are going to introduce correlation and regression. So we are introducing the concept of correlation and simple linear regression. Many of you are interested in doing some studies, some research, or some kind of like investigations. So this is an important lesson. Please be attentive. So we are using Stata to do correlation and regression, simple linear regression. So this time we're going to use a different data set. So we want to use a data set called auto, which is uh, data set that come with Stata application. So it's in the system. So for you to use it, to access it, you have to type this command. This command means we want to use the dataset auto. So this dataset is in the system. Okay, so to call this dataset, we use this command, system use. So system use, we just say sys, then use as one word, auto. So if we press enter, we can see that now we have access to the dataset that is in the system. So we can have a look at the dataset. So we can browse it. We can see that this dataset is indeed a nice dataset. There are about 74 observations for each and every variable here. So we have got a very nice dataset. Okay, so there are these variables. We can describe the variables. So these are the variables: make and model, price, mileage per gallon, repair record, headroom, trunk space, weight, length, turn circle, displacement, gear ratio, and car origin. So this dataset is about motor vehicles. That's why it's called auto. This dataset is containing information on these variables for these motor vehicles. So there are two things that we want to do. We want to do what we call correlation. So what is correlation? We want to see whether two numeric variables are correlating, meaning that they are influencing one another. The movement in one variable is causing is explaining a movement in another variable. And there is this term that is emphasized by economists and statisticians. They say that correlation does not mean causation. Never interpret correlation as causation. Don't say this is causing that. No, but we are just correlating. So we want to investigate whether there is correlation between weight of a car and the length of the body of the car. We want to investigate whether there's a linear relationship, a linear correlation. So to call for this correlation, we type correlate, then one of the variables which is a dependent variable and the one which we think is an independent variable. So we have got two variables. We're going to see the correlation between them. Okay, so we are given the results as you can see in this window. So these results are telling us that between weight of a car and length of the car, there's this correlation which is 0.9460. This is 0.9460. So the maximum correlation that you can get between two variables is 1. The maximum correlation is 1. It can be positive 1 or negative 1, but correlation ranges from from -1 to +1. So there can be zero correlation, or negative 0.5 correlation, or positive 0.5 correlation, 0.8 correlation. So in this table, we can see that there is a positive correlation of 0.9460. In percentages, we can say that there is a correlation of 94.60% between the weight of a car and the length of a car. This means that these two variables have got some linear relationship. Let's see the scatter plot for these variables. So we want to see the scatter for weight and height. We want to see their scatter plots. So we call for a scatter. We call for a scatter for these two variables, weight and weight and length. So we can see that indeed there is a positive linear relationship between the variables weight of a car and length of a car. So the length is in inches and the weight is in libs. So there is a linear relationship, as you can see. The relationship is linear, and that's why we were getting the positive correlation coefficient. This is called R. This is Pearson correlation. So the correlation coefficient is 0.9460, which means that weight of a car is correlated to the length of the car. Okay, so we want to learn a regression, a simple linear regression. We want to see by how much can we explain this correlation between the two variables. We want to investigate the quantity of the relationship between weight and length of a motor vehicle. So we're going to say regress. The command for regression is regress. So we want to regress, and we have to specify the dependent variable. So our dependent variable is weight. So we double click weight, and our independent variable, the variable that is explaining the dependent variable, is the length now. So we are learning a simple linear regression. It is called simple because you only have one dependent variable and one independent variable. So our dependent variable is weight and our independent variable is length. So we want to see how the relationship can be quantified. So we press enter. After pressing enter, we are given the regression results, the output for the regression, the simple linear regression that we have just conducted. So you can see the command that we type, regress weight length. So we can see that we are given this output. Okay, so we have to start interpreting the output. First of all, we have to check whether the model is significant. This regression is significant. And the value that tells you that this relationship is very significant is this value, the probability of greater than f. This probability is the one that tells you that the regression that you have carried out is significant. So the overall model is determined by this value here. So if you have got this value is very small, if this value is less than 0.05, it means your model is very significant. So in this case, our model, the probability of greater than f is 0.0000, which means this is very highly significant, because 0.000 is less than 0.05. So we can say that our model is significant at 1%, because even 0.000 is less than 0.01, which is 1%. And the next thing that we must pay attention to is the value of the adjusted R square, or the R squared value. These values, they tell you how much is this regression explaining the variation in the dependent variable weight. So the R square here is 0.8949, and the adjusted R square is 0.8935, which means 89% of variation in the independent variable is being explained by this regression. So when if you get this such a high value, that just know that your model is just okay and is indeed explaining the regression, is explaining the variation, the two variables. Of course, you have to do some study on the regression. It's not as simple as I'm explaining here. There are some issues that you must investigate after learning a regression analysis. Remember, I said this is a simple linear regression because we only have two variables, weight and length. Okay, so after checking that the model is significant, after being told by this small p-value here, and after seeing that much of variation in the model is being explained, so we can say this model is just okay, and we can see the f value. When you have got a large f value here, just know that your model is just okay. So f value of 6.613 is very, very, very large, meaning that our model is indeed very significant. Now we come to this section where we begin to interpret now the significance of the variables. So we only have one independent variable, which is also called explanatory variable, length. So this length has got also a p-value. The p-value is denoted like this. So the p-value for length is this one, and it's also 0.00. This value is less than 0.05. So whenever you have this value less than 0.05, just know that the variable concerned is also very significant. It's significant at 5% if it is less than 0.05. If it's less than 0.01, it's significant at 1%. So in this case, this is 0.00 is less than 0.01. So it means length of a car is very significant in explaining the weight of a motor vehicle. Of course, it's not as simple as I'm explaining, but this is what I'm saying. So we can see the t-value. The t-value for length is 24.76. This is very large. This t-value is very large, meaning that now our model is indeed significant. So you can see, you can tell whether your variable is significant by looking at the t-value and the p-value. So the p-value is very small, less than 0.05, less than 0.01. It means this variable is significant in explaining weight of a car. And the t-value is 24, which is above the hypothesized or theoretical t-values. And we have got the confidence interval here. So we can see that this coefficient, we have got a coefficient here, which is explaining the quantity of change in the weight of a car in relation to 1 unit change in the weight, in the length of the car. So 33.01988 here means that if the length of the car, and we are told that the length is in libs. So if the length of the car increases by 1 lib, it means the weight of that car will increase by 33 libs. Okay, now let me explain properly. The length of the car is in inches and the weight of the car is in libs. So here it means if our car, the length of the car increases by 1 inch, the weight of that car will increase by 33 libs. That's what this coefficient is telling us. If you change length of a car by 1 inch, then the weight of the car will increase by 33 libs. That's what this value is telling us. And there's this confidence interval. So as long as you have this value between the confidence interval of 30.36 to 35. So 33 is indeed in between 30 and 35, which means that indeed length is a very significant variable. And we have a constant. This constant is telling us that if the coefficient of length of the car is equal to 0, then the weight of a car is going to be negative 31.86. This is meaningless. So sometimes the constant will tell you nothing. So if the length of the car is 0, it means there is no car there. So why bothering interpreting this? I hope you have grasped the concept, correlation and regression. Thank you.